Today we will be doing problem number 2, speeding ticket in the simulation section in Usaco guide. Always a troublemaker, Bessie the cow has stolen Farmer John's tractor and taken off down the road. The road is exactly 100 miles long, and Bessie drives the entire length of the road before ultimately being pulled over by a police officer who gives Bessie a ticket for exceeding the speed limit, for having an expired license, and for operating a motor vehicle while being a cow. While Bessie concedes that the last 2 tickets are probably valid, she questions whether the police officer was correct in issuing the speeding ticket, and she wants to determine for herself if she was indeed driving faster than the speed limit for part of her journey. The road is divided into n segments, each described by a positive integer length in miles, as well as integer speed limit in the range 1 to 100 miles per hour. As the road is 100 miles long, the lengths of all n segments add up to 100. For example, the road might start with a segment of 45 miles with speed limit 70, then it might end with a segment of length 55 miles with speed limit 60. Bessie's journey can also be described by a series of segments, m of them. During each segment, she travels for a certain positive integer number of miles. At a certain integer speed, for example, she might begin by traveling 50 miles at a speed of 65, then another 50 miles at a speed of 55. The lengths of all m segments add to 100 total miles. Farmer John's tractor can drive 100 miles per hour at its fastest. Given the information above, please determine the maximum amount of the speed limit that Bessie travels during any part of her journey. The first line of input contains n and m separated by a space. The next n lines each contain 2 integers describing a road segment, given its length and speed limit. Next m lines each contain 2 integers describing a segment in Bessie's journey, giving the length and also the speed at which Bessie was driving. Please output a single line containing the maximum amount over the speed limit Bessie drove during any part of her journey. If she never exceeded the speed limit, please output 0. Doing this problem is quite simple. All we need to use is simulation. We will be simulating at each segment in the total 100 mile length and checking and comparing the speed limit to Bessie's speed. So as we can see in our input, we have 40, 50, and 10, which is shown over here. 40 miles, 50 miles, and 10 miles. And then in Bessie's case, she was driving 40, 20, and 40. The only reason I did this dash is just so you could see the separation between the speed and then Bessie's speed. Alright, yeah. So what we want to do in this problem is basically just compare 1 to 1 at each mile. So at the first mile, we see that the speed limit is 75. In Bessie's case, the first mile, she's driving at 76. Then the second mile, 75. Second mile for Bessie is 76. So this continues for the first 40 miles in both cases. So at the 40th mile, speed limit will be 45. For Bessie's 40th mile, speed limit will be at 76. Now we have a new segment with the new speed limits. So the next one will be at the 41st mile. The regular speed limit will be 35. But in Bessie's case, the 41st mile will be at a speed of 30 miles. And then for Bessie, this will continue on until mile 60. That'll be the last mile where she's traveling at 30. Whereas this one will continue on until mile 90, which will be the last mile. And as you can see, well, there's a discrepancy over here. This one ends at 90, while this one ends at 60. So, well, how do we tackle that? Basically, we'll just be doing a 1-to-1 relation. So as we can see, this is at mile 1, and this is at mile 1. 2, 2, 3, 3, 4, 4, 5, 5, so on, so forth, right? So in an array, all we will be doing, right, is this array will be at a length of 100 because we know that from the constraints in our problem. So all we'll be doing is for the first 40 miles, we'll be going through a range given by the input. And for the first 40 miles, we'll just be putting 75, 75, 75, 40 different times. Then 50 times, we'll be putting 35, 35, 35, so forth. And then for 10 miles, or 10 of them, it will be 45, 45, oops, 45, 45, like that. And this will be the speed. Now, for Bessie's speed, we'll be doing the same exact process. 40, the first 40 will be 76, 76, 76. Then the next 20 will be 30, 30, 30. And then the last 40 will be 40, 40, 40. And basically, by doing this, we'll be able to compare at each mile what the speed is versus what Bessie's speed is, right? So when we do it, this will actually look like the following. If we run this, right, we can see that there's a one-to-one relationship, right? So for each mile, we can see the speed limit and then Bessie's speed. So 75, 76, 75, 76, right? And then that keeps going, and then until the 40th mile, now there's a change, 35, 30, 35, 30. Now, even though Bessie's speed changes at 20 miles, we'll still have that one-to-one, right? Because you'll see that 35 continues for 50, whereas this 20, there are 20 of 30s. Yeah. And then we can just compare it like that, 35, 40, 35, 40, 35, 40. And then finally our last segment, right? Bessie's speed will change again. Oh wait, no, Bessie's speed will not change, but the actual speed limit for the last 10 will change to be 45. 45, 45, these are the last 10. And Bessie's 40s still continue. And basically, by doing that, we'll get a one-to-one. Then we just need to loop through both of these and then just check each one and get the max out of it. So we can see that in this code, right? First, we just create the speed limit for Bessie and the speed limit that is just set in place. Then we're just getting our inputs. After that, all we're doing is just setting all the values that we want for speed limit and speed Bessie. And we do this by taking the integers given in the input. So length will be 40 in the first case, speed will be 75. And then for j in range length, so for the first 40 values in speed limit, it will be mapped to have a value of 75. And then we keep continuing this for 50, 35, 10, 45. Then we'll have the speed limit that is set in stone. Next, we want to just take for I in range m, which will be the m segments that Bessie goes through. We're just going to be taking Bessie's length and Bessie's speed, and then for the first 40, we'll be mapping her speed to 76. Then for the next 20 miles, her speed will be 30, so then we'll have 30s, and then we'll have 40s. And then after that, what we'll do is that we'll just loop through over for I in range 100. And the reason it is 100 is because we can see in this that the road is just 100 miles long. That means that we'll have 100 unique values every single time. So we only need to go for I in range of 100 and nothing more or less. Once we do that, what we'll be doing is we'll have this value max over, and then we'll just be taking the max, right, between max over, and then whatever Bessie's speed limit is at one value minus whatever the actual speed limit is. So in the first case, Bessie's speed limit will be 76. The actual speed limit will be 75. So then these two subtracted by each other will be 1. So max over will be 0. This will be 1. So then max over becomes 1. And basically by doing that, we'll be finding our max speed that Bessie went over the speed limit, right? So if we run that, we can see that it is 5. And yeah, we do get that answer. And where does that 5 come from exactly? Well, if we run it, we can see that this occurs at 40:35. So when Bessie is driving at a speed limit of 40, while the speed limit is actually just at 35. And yeah, this should work for all cases, and it does.